This is one of the nation's bestsellers, first printed on September 27, 1962. Silent Spring has been called the most controversial book of the year. Biologist Rachel Carson worked 4 years in the preparation of Silent Spring. What she wrote started a national quarrel.
Chemicals are the sinister and little recognized partners of radiation in changing the very nature of the world, the very nature of its life.
Silent Spring arrived in a world that was already aware of the health dangers of radiation. In 1945, the atomic bombings of Hiroshima and Nagasaki killed anywhere between 100,000 to 225,000 people, mostly civilians. But the misery didn't end there. In the war's aftermath, clinicians began to see an uptick in cases of leukemia among survivors.
This woman was pinned under her house, 600 meters east of the epicenter. Excoriations are observed around her ears and other places. On October the 3rd, leukocytes were 1,500. Symptoms, apathic facius. Her entire family died, leaving her the sole survivor.
So, by the 1960s, scientists were well aware that radiation could cause cancer. But synthetic chemicals had not gotten the same attention, despite being an increasingly ubiquitous part of the world. And there was no mechanism in place to determine whether they were safe before they became widely available.
One scientist a couple of decades ago put it to me in his office. He said, there's only a couple of different kinds of radiation.
This is Scott Frickel, a sociologist at Brown University and the author of Chemical Consequences.
We know a lot about radiation, but there's only a handful of different types of radiation. There are hundreds of thousands of kinds of chemicals out there, and we know next to nothing about those.
Geneticists had already been investigating synthetic chemicals for years, but Rachel Carson distilling their research in Silent Spring changed things. The book became a rallying cry for the growing environmental movement. It not only helped get DDT banned, it led to the creation of the Environmental Protection Agency. So this is the soup that a scientist by the name of Bruce Ames was swimming in. Here he is in a clip from the McNeil-Lehrer report.
And the reason I came into this field is I was worried about man-made chemicals and worried about damage to genes and damage causing cancer.
During this period, there were lots of people trying to figure out how to get a handle on what was potentially, an invisible crisis that was happening under our noses. And science was ill-equipped with the methodologies and approaches that radiation geneticists had developed over decades. That those weren't going to work. They weren't going to help us get a handle on the scale of the problem that people were concerned about.
All of this was on Bruce's mind in 1964 when he was doing something that we all might do to get our brain juices flowing.
I think it was a list of all the ingredients in potato chips. I think that's what got me. I got interested in, is there anything out there that's a mutagen? Nobody had ever thought about testing that kind of thing.
To put it simply, Bruce realized that it was entirely possible that the chemical preservatives in potato chips could cause cancer in humans without anyone knowing. So he wanted to test them, to find out if they were mutagens, agents that could damage DNA. And Ames believed that DNA damage was the first step towards cancer. But there was no practical way of testing for such a thing. Or, we should say, no way that didn't involve a ton of time and huge sums of money. So, starting in 1964, Bruce started working on a new test. It finally came out in 1973, and it was cheap and fast. The Ames Test, as it was called, made Bruce Ames a hero to the emerging environmental movement. That soup he was swimming in, they had a scientist on their side, someone who created a powerful but accessible tool to weed out harmful chemicals and prevent industry from poisoning people. And that's why it was such a surprise when, by the mid-1980s, he had done a total 180. He started speaking out against his colleagues, saying their concerns about cancer-causing chemicals were overblown.
In other words, he says, pollution isn't as bad as the environmentalists say. Environmentalists have been taken aback.
He's certainly shaken things up. he certainly has become the darling of industry, probably not for the reasons that he would like.
So what happened to Bruce Ames? How did he go from environmental champion to a darling of industry? Was he seduced by political arguments? Or was he just a scientist following the science? In typical Distillations fashion, I'm here to tell you there's no easy answer. It turns out that both cancer and Bruce Ames are really complicated. From the Science History Institute, I'm Alexis Pedrick, and this is Distillations. Chapter 1: The Environmental Hero and His Test. Let's back up a little bit. To that point when Bruce Ames had that life-changing moment with a bag of potato chips. 3 years after his revelation, in 1967, he got hired at the University of California, Berkeley, to be a professor of biochemistry and molecular biology.
You had just arrived in Berkeley and had set up your lab and relocated.
This is an excerpt from a UC Berkeley oral history with Bruce Ames from 2021.
So, 1967. So, did you arrive in the summer of love?
There were all sorts of things going on.
Berkeley was a hotbed of activism in the 1960s. Students and local residents were all riled up over things like the civil rights movement, the free speech movement, and anti-Vietnam War protests.
He stood up there, the police took him away. That shows the entire process that's going on campus.
And we're going to conduct our lives for a while in the second floor of Sproul Hall. We'll do something which hasn't occurred at this university in a good long time. We're going to have real classes up there.
There, a small minority of beatniks, radicals, and filthy speech advocates have brought shame on a great university. It began a year ago.
By 1970, in the early 70s, the environmental movement is really cooking. And I remember doing interviews with some of the students who would tell me about the marches that, on campus, they would go to these environmental marches.
Students gave up their noon hour to a litter pickup march that produced more than 500 pounds of trash in a 10-block area. A mock factory was running to show how industry discharges waste into the nearest body of water.
Clearly, environment is more than land, air, and water. It's attitude. And it begins at home. It begins in every single one of us.
And Bruce Ames was hard at work in a brand new field of science that combined biochemistry, genetics, and toxicology, soon to be known as genetic toxicology.
Once I was offered a toxicology professorship at Harvard or someplace like that, and I thought, I'm a toxicologist now.
I don't think the first generation of scientists really thought of themselves as environmental scientists. But, some of them did latch on to this environmental framing because it helped sell the science that they were promoting.
For Bruce Ames, that science was his test, which he was hard at work on in his lab. Like we said, he needed to overcome two big issues: time and money. The process the existing test used was pretty extensive. Essentially, it worked like this. You take at least 50 mice, some labs will use up to 500, and expose them to a chemical for a prolonged period. At the end of that time period, you check the mice for tumors and try to determine what organs are infected and what kind of tumor might have developed.
But it's really expensive to do this. The animal care facilities are not cheap, and you have to house these animals and expose them to the chemicals for 2 years.
This is Angela Krieger, a biochemist and a history of science professor at Princeton. She's currently writing a book about the Ames test.
Even in the 1970s, that kind of test might cost $250,000 and take 2 years. This is, to this day, kind of the golden standard for demonstrating that something is carcinogenic.
The golden standard, yes, but not a very good candidate for wide use.
At any one time, you could only be testing a handful or a few dozen even substances out of 60,000 on the market. So basically, as long as this was the way in which chemical testing would happen, at least for carcinogenicity, there were a lot of chemicals that would never go through this testing.
Bruce understood this, and so when he made his test, he worked on two assumptions about how human cancer could be triggered by exposure to environmental mutagens. Assumption number one was that if a compound did not induce a mutation, then it was unlikely to cause cancer. Remember, he believed that in order for a chemical to be considered a carcinogen, it had to cause a mutation in the DNA, i.e., all carcinogens are mutagens. And this turned out to be key, because it was hard to test directly for carcinogenicity.
So the breakthrough of the Ames test was that even if it didn't get you all the way to carcinogenicity, just to be able to test for mutagenicity, does this chemical cause a mutation, that could be seen as a proxy. If mutations cause cancer, then at least let's look for mutagenicity, and if a chemical is mutagenic, then it can be identified for further screening at the very least.
Bruce's second assumption was that a microbe was a suitable model organism for analyzing mutagenicity as it occurred in human cells. Suitable model and way less costly and time-consuming than mice. And this went a long way towards the goal of an easy, inexpensive test, which lots of people, not just Bruce Ames, were thinking about. This is Scott Frickel again.
You see at this moment all sorts of different kinds of tests sort of bubbling up in the literature, where people are trying to figure out ways to develop these tests for mutagenicity that are fast and relatively inexpensive.
But Bruce Ames came out on top.
Today it's called the Ames Test and is used all over the world. In a quick, inexpensive test he invented for identifying mutagens, substances that damage genetic material and often cause cancer.
One key reason for his success was that Bruce Ames gave his test away for free.
He didn't patent that test. He gave it freely to anybody who wanted it. His intentions in developing that test were definitely to try to promote the scientific sophistication of toxicology. And I think he had an incredible impact there. He was providing his strains to everyone, people in government agencies, also to university scientists, also to tobacco companies, food companies, major chemical companies, drug companies. It's like they were all requesting the Ames strains.
Everyone wanted a piece of Ames. By 1976, the test was being used by more than 60 major companies, and environmental groups finally had a way to prove their case, all thanks to Bruce.
For it was he who discovered that some hair dye and flame retardants were likely carcinogens, laboratory revelations that fueled the environmental movement's demands for tougher product safety laws.
And it was in the realm of product safety laws where Bruce was about to have one of his biggest wins, along with another scientist by the name of Arlene Bloom. Chapter 2: Mountains and Molecules. Arlene Bloom is a biophysical chemist and a mountain climber.
I do mountains and molecules.
In 1972, she was on a climbing expedition in India when tragedy struck. Her friend died during a climbing expedition.
And he was a strong environmentalist, and in his memory, I wanted to do something for the environment.
At the time, Arlene was a biochemistry postdoc at Stanford. Now, being in India made her aware of overpopulation as an environmental issue. The injectable birth control Depo-Provera was relatively new and seemed promising, but people were concerned that it might cause cancer. So Arlene wanted to test it out and determine if it was safe to use. She'd met Bruce Ames and knew about his test, so she asked if she could use it on Depo-Provera.
And he said, sure, but what I'd really like you to do is look at this flame retardant, tris-2,3-dipropylphosphate.
In the early 1970s, there was a series of tragic incidents where children died after their pajamas caught fire. In response, the federal government required that all children's pajamas be fire safe.
Makers of sleepwear for children up to the age of 6 were given until the end of July 1973 to make their product flame-proof.
You put a blowtorch on the cotton for I don't know how many seconds, and if it didn't go up in flame, it was all right. But no fabric passed their test.
So, companies responded by adding a flame retardant to pajamas, which was made out of a chemical called brominated tris.
I said, that's crazy, putting some unknown chlorinated and brominated chemicals in pajamas where you're treating 50 million kids, rubbing on their skin and absorbing all this stuff.
And he said it's 5 to 10% of the weight of kids' pajamas. I think it's getting into the children. I think it's harmful. I think it could be a likely mutagen. So I was very depressed because my friend had died. And even though I thought the flame retardant thing sounded extremely weird, I said, sure, I would test the tris.
And what she discovered was alarming.
Tris was one of the strongest mutagens we'd seen.
She followed up with more studies, including one with a child in the UK who had never been exposed to the chemical because pajamas in that country weren't treated with tris. A urine test was conducted after the child wore pajamas from the United States.
And the first morning, there were high levels of breakdown products of tris in the little girl's urine, and they were chemicals that were known to be cancer-causing. So I suddenly realized, and this was all the kids in the country were wearing these tris pajamas. And so I realized that all the kids in the country were getting in their bodies these cancer-causing mutagenic chemicals. So that got my attention, to say the least. I felt we had to tell the parents of America and change it.
At the same time that Arlene Blum was investigating tris, she was also climbing Mount Everest.
I got invited then to be the first American woman to try to climb Mount Everest. And I couldn't decide which to do, so I actually wrote a lead article while I was on Mount Everest and sent it by mail runner to base camp and on to Kathmandu, and it was published in Science a few months after our team was the second American team to climb Everest. And in those days, immediately we were on all 3 TV networks talking about it, and every parent in America knew. And 3 months after the paper came out, brominated tris was banned from kids' pajamas by the Consumer Product Safety Commission, which is how things ought to be.
She thought they'd won the battle.
There is another danger to children that we're going to tell you about tonight, a danger that the government thought it had removed. Bettina Gregory has that story.
Children's pajamas treated with the flame retardant tris were banned 4 years ago. That was supposed to be the end of it.
However, that summer, I went and bought about 20 pairs of pajamas at Penny's to see if brominated tris was in them or out of them. And I thought, I'll just take a little sample from the seam so I can give these pajamas to my friends as presents. But about a third still had brominated tris, probably left over. But half of them had a new, very similar chemical, which was chlorinated tris, which was identical pretty much in structure, function, and considered problematic. And we wrote another paper for Science, and chlorinated tris was also removed from kids' pajamas back in the 70s, quite quickly.
It was a bit of a game of whack-a-mole, but regardless, brominated tris was banned in 1977. And by this point, the Bruce Ames lab was on a roll. The Ames Test was used to show that cigarette smoke and hydrogen peroxide-based hair dyes were mutagenic, and Bruce Ames himself got the hair dye industry to change their formula. Things were working as they ought to, just like Arlene said. But then Bruce discovered something that completely changed the way he viewed cancer and chemicals.
And the reason I came into this field is I was worried about man-made chemicals and worried about damage to genes and damage causing cancer. And I've worked in the field for 20 years, and I think what's becoming apparent is that those of us who entered worrying about that didn't realize about nature and that the world is just filled with natural carcinogens, and the amounts of those are just enormously more than the man-made chemicals.
Chapter 3. Bruce Flips. We need to back up for a minute. When the Ames test first came out in the world, scientists immediately started using it on just about everything. Many of them would share their results with Bruce, and sometimes those results were surprising.
People started finding mutagens in plants, in edible plants even. So, and then I realized that cabbage has 100 toxic chemicals in it to kill you. Anyway, I got a more broad view of reality.
The list was piling up. Coffee, alcohol, tomatoes, even broccoli.
So that kind of raised concerns for him as to whether one should be trying to regulate very low-dose exposures to mutagenic synthetic chemicals if a lot of natural chemicals were also mutagenic.
So so the public thinks that nature's benign and all the chemicals are man-made chemicals. But every plant in nature has to defend itself against all the millions of insects with toxic chemicals. So every plant is a few percent in toxic chemicals. And now that people are doing more testing, they're realizing that there are mutagens in this plant and carcinogens in that plant. And so if you look at the amounts of nature's pesticides versus man-made pesticides, we're probably getting 10,000 times more of nature's pesticides than man-made pesticides. So the potato has solanine and chaconine, and the tomato has tomatine, and lettuce has something else.
This knowledge changed Bruce Ames's entire paradigm. It was no longer chemicals that cause mutagenesis are bad, but rather the amount of exposure to that chemical must be bad.
So obviously, we have to watch out for a worker who's breathing enormous amounts in, but when you're starting to measure 1 part per billion, and we can do that now because of all of our new instruments, 1 part per billion is like 1 person in all of China.
He reasoned that exposures to mutagenic chemicals in small doses were probably harmless. After all, were tomatoes and lettuce bad for you?
The Sierra Club, big polluters every time they make a campfire because they're pouring carcinogen up into the air. And every time you drive your car to work, you're pouring carcinogen out your car. Every time you fry your hamburger. So you have to finally decide what's important. Well, it takes about a year of Los Angeles smog to get the same amount of burnt material that a smoker gets in 1 day. So that right away tells you, well, smoking's probably some big thing, and smoking is a big thing.
Environmental groups were not happy with Bruce's messaging. He was muddying the picture, sowing seeds of doubt.
It's like saying smoking's very bad for you. Let's not worry about anything that's not as bad as smoking. He's trying to paint a picture that everything causes cancer, so don't worry about anything. And of course, there's a lot of industry that would like to get that theme out because it makes people confused. It makes people think, gee, I can't figure it out, so I'll just ignore the word cancer every time I hear it.
And that's exactly what happened. Every time Bruce appeared on TV, it was like music to the ears of the chemical industry. And they used him to their advantage. In one speech, the vice president and technical director of the Manufacturing Chemists Association cited Ames extensively and quoted him, saying, "Natural carcinogens are everywhere. They're present in mushrooms, parsley, basil, celery, cola, wine, mustard, beer, peanut butter, and many more remain to be discovered." This was the tactic that they used to discredit Silent Spring, and now, thanks to him, they had a new variation. Even the tobacco industry liked Ames. In one confidential memo, a Philip Morris employee wrote, "Is there any conceivable manner in which we could get this guy on our side of any of the science disputes confronting tobacco?"
Industry picked up on his statements and used them all the time. And to this day, he is someone that they like to quote. There's no question at all. Some of the things he was saying were very convenient.
It looked like Ames was giving the chemical industry the scientific uncertainty argument they needed to deflect regulation. But isn't scientific uncertainty the natural state of science? Was Bruce Ames just being a scientist? He claims he wasn't on industry's side, that he was only loyal to his science.
If I got money from industry, then I was corrupt. And I wanted people to believe in all this stuff because I thought it was the reality.
You want to establish the truth of your science.
Yeah, exactly.
And your credibility was your coin.
Right. I was altruistic, but it was self-interest.
So maybe he never got paid for what in effect were endorsements, but he changed his views. And from the perspective of the environmental movement, it couldn't just be the revelations about cabbage and tomatoes. Something else had to account for such a dramatic shift. But what if it wasn't something else? What if the environmental movement claimed Bruce Ames, but Bruce Ames never claimed them? Remember this clip from his oral history?
So, 1967. So, did you arrive in the summer of love?
There were all sorts of things going on, but I was all taken up by my science, so I tried to ignore all that.
He may have been at Berkeley during the 1960s, but Bruce Ames was not part of the protest.
In Berkeley, I was a bit of a mutant.
You were a bit of a mutant.
I was always skeptical of the left.
He was always skeptical of the left.
There were protests against the Vietnam War that become violent, and there's a lot of that. So were you there did you come to campus? Were there times when you could not come to campus?
Let's see, I think the students had taken over something or other, but our building was right on the edge of campus, so I could always get in and do my thing.
Right, so you were on the periphery and you were relatively unaffected by that.
So that hotbed of unrest?
We were standing in the front row when the cops came to clear us out, and I got maced.
Bruce Ames, darling of the environmental movement, was doing his best to ignore it, sneaking into his lab to work on his science.
At what point did the left earn your skepticism? Did the left change or did you change? Or was it always a problem for you?
Well, my family had a couple of uncles who were communists, and my parents were mildly socialist. Somehow I never bought into all of that. So I was very skeptical of all these leftist big ideas that were going to change the world, and I just thought it was all very naive.
As Arlene saw it, Bruce did make a political shift. Maybe he didn't start out all the way on the left, but to her, he definitely got pulled to the right.
Somebody joined our lab. Oh, goodness, what's the word? You know, people who don't believe in government. What do they call them? Forgetting the name.
Well, there's like libertarians.
Libertarians, exactly. Somebody joined our lab for free. Bruce always liked to bargain, and he was a libertarian. And he introduced Bruce to Milton Friedman.
Milton Friedman was an economist whose doctrine was basically the social responsibility of business is to increase its profits.
There were some people in the environmental movement who were not doing great science, who misrepresented Bruce's work. So he got a push from the environmental movement and a pull from Milton Friedman, who's quite a clever guy, if evil.
He was good at spinning everything to make it seem like it was all the government's fault. Remember how the government made chemical companies create fire-safe pajamas? And how they complied by putting cancer-causing chemicals in them? This is how Friedman spun it.
4 or 5 years ago, the government required all producers of children nightwear to add tris to the nightwear in order to make it flame-proof. 4 years later, the government discovers that the chemical tris is carcinogenic. So it's obvious, and when the government steps in and makes mistakes and has failures, they're going to be big failures and not little ones.
Arlene thinks that Bruce was swayed by one too many dinners with Milton Friedman. But in his oral history, Bruce remembers things differently, starting with why he wanted to investigate tris in the first place. To him, it didn't make any sense that the government mandated fire-safe pajamas.
I mean, you might save a dozen kids from burning up when their cigarette-smoking father falls asleep on the couch and sets the house on fire. But it wasn't reasonable to save 50 million kids. And so I was attacking this government agency, and they fought back. The government agencies don't change things very easily.
Bruce claims that everything came down to resources. How much can we afford to spend as a society to protect our health? If the answer is not an infinite amount of money, then you have to prioritize.
Yeah, I had a sort of economist view of things. If you spend your time on 1,000 hypothetical risks, you're lost because you have to find out what's important and go after those.
Right.
And that seems obvious to me, but it is thinking more like an economist.
And you mentioned the slow adoption of the Ames test by regulatory agencies.
Yeah.
The corporate.
Oh, they lapped it up. Yeah. See, that strengthened my more libertarian instincts because industry had a big incentive on weeding out toxic chemicals. And regulatory agencies are monopolies and they move very slowly.
So, despite overlapping for a while, Bruce and Arlene drifted apart. On the political spectrum, yes, but also in life. Bloom left Ames's lab and then science altogether. In 1980, she became a full-time mountaineer.
So I had a position at Berkeley in Bruce's group, and I asked for a leave to take a year to walk across the Himalayas. And somebody said, you need to make up your mind. You want to walk across the Himalayas or do science? And science was looking a lot less appealing under Reagan. So I thought 4 years of Reagan, I will do all my adventures, and then certainly he won't last more than 4 years, and then I'll go back to science.
And what about Bruce? Maybe his association with the left was just an association. Maybe he was just in the right place at the right time. Maybe it wasn't the scientist that changed. It was the science. Chapter 4. What actually causes cancer? So if Bruce Ames was complicated, it turns out that cancer is even more so. In the 1980s, as the media tried to navigate the concern over chemicals and cancer, they'd invite a doctor or an academic to talk about the topic, and sometimes Bruce Ames would be there too, as an other-side talking head. Here he is at the McNeil-Lehrer NewsHour in 1983.
Mr. Ames, do you agree with Dr. Epstein that we are in the middle of a cancer epidemic?
No, I completely disagree.
And again in 1984.
So it isn't so much that you identify a chemical as a carcinogen. We want to know that, and that's a red warning sign, but you also want to know the amount. Is it significant?
And again in 1987.
With 50% of the chemicals coming out as carcinogen, it's crazy to think of eliminating every carcinogen, and we'll just bankrupt the country if we go after all the trivia. You have to decide what's important.
And he also held lectures on campus, like this one.
Okay, so whatever the causes of cancer, they're not due to the modern chemical world. They've been around a long time.
He really seemed to relish being in the spotlight and telling environmentalists that they were wrong.
Well, I think many of us came into the field because we were worried about new chemicals coming into the environment. I did. And we were one of the people who turned up tris in children's clothing, and I fought the companies on that, and we found hair dyes, and I fought the companies on that. I don't consult for industry. But what's happened in the last 5 years has been a revolution in understanding.
Bruce was changing his understanding, which is good. It's what scientists do. The arguments Bruce made certainly made the chemical companies happy. There's no denying that. But upon further investigation, the Ames test does have a fair bit of limitations. Let's start with the first one. One of the big assumptions that Ames had about his test was that all carcinogens are mutagens. But it turns out that's not the case. The science has changed. For one, remember how we said mutagenesis is basically DNA being damaged? Well, our bodies have a built-in fix for that.
So there's a really elaborate DNA repair apparatus in the cells to protect against harms from that.
I know. You're probably thinking, after all this, you're telling me our bodies can just fix any DNA damage? But hold on. As Angela Krieger explains, comparing the damage done by broccoli to the damage done by synthetic chemicals is not that simple.
One way to think about it is that natural substances are substances, at least if they're things that humans have been eating for hundreds and thousands of years, we've co-evolved with these substances. Most of them are biodegradable, and in many cases we have all kinds of DNA repair mechanisms that are aimed at trying to correct any damage that comes from the substances that we encounter through food, through infection, that sort of thing. The 20th century saw an incredible proliferation of synthetic substances that had never existed on the face of the earth before. They weren't part of our evolutionary history. They weren't part of our kind of repertoire of defending ourselves. So you can say on evolutionary grounds that maybe we should be a little bit more cautious about things that the human species, that Homo sapiens haven't been exposed to in their history.
The brilliance of the Ames test was that it could detect mutagens, which in turn could then be tested further to see if they were carcinogens. But not all carcinogens are mutagens. In fact, only a small number are. This is Alan Balmain, a cancer researcher at the University of California, San Francisco.
If only 15% or 20% of the carcinogens out there are actually mutagens, that's what the Ames test would detect on its best day.
The second limitation has to do with using bacteria as a proxy. If it developed mutations, then humans could also develop mutations, which Ames believed would be cancerous. But now we know that bacteria is not always a good proxy.
Part of the difficulty is that when animals are treated or humans are exposed to these types of chemicals, many of the chemicals that are mutagens require metabolic activation. And generally you miss that if you do a bacterial assay, the classical Ames test. But the Ames test will not distinguish all chemicals that are mutagenic in animals or in humans. And also it will miss some chemicals that are mutagenic in animals and humans because the conditions are not correct. Some chemicals that were positive in the Ames test did not give cancers that had lots of mutations. And some chemicals that were negative in the Ames test did give cancers that had mutations.
Now, does all of this mean that the Ames test isn't worthwhile?
I mean, the Ames test has been the workhorse of mutagenesis for many decades, so it has been very useful in so many ways. But there are some limitations in the Ames test.
So it's kind of like we're back to square one, the original problem. The test is good, but has limitations, and we still need a test that's fast, reliable, and inexpensive. And that's where Balmain comes in. He and other scientists have revived an old theory about how people get cancer. You need three things: a mutagen that's also a carcinogen, something that causes inflammation, and time. Look at cigarettes. They contain known carcinogens, chemicals that cause inflammation, and they're addictive.
Somebody smoking 10 cigarettes a day, 20 cigarettes a day, they are completing exactly this repetitive inflammation step. I mean, every time they smoke, they're increasing the probability of a mutation in one of the genes that controls cancer, so increasing that frequency. But they're also, repeatedly exposing themselves to something that causes irritation of the lung, the airways in certain cells. They get damaged, they start to grow. And that's where the cancers come from.
Balmain is interested in the missing factor of inflammation, and he's working on a new test, sound familiar, to determine the causes of inflammation. And bacteria not being a good proxy isn't a problem, because Balmain is taking stem cells and creating human tissues, which he calls organoids, and then exposing them to the chemicals.
And now we can treat these organoids, human organoids, with these chemicals, initiators, with promoters, with agents that cause tissue damage or cause inflammation, and measure the effect directly in organoids of human cells being exposed to these same chemicals. And, the initial studies are very, very promising.
Chapter 5, A Comforting but Untrue Story. So there you have it. Nothing about Ames or cancer or his test is easy. But big picture, it had a starring role in the history of us trying to understand cancer, trying to keep ourselves safe from harm. Here's Angela Krieger again.
I'm following the Ames test because I think it's an interesting way to see how the attempt to use a tool succeeds and fails in different ways. But I'm not trying to say that if we had only had better regulation that used the Ames test, that we would have avoided having more cancers. In fact, our whole picture of what cancer is and what causes it was getting more and more complicated in these decades. So it's a situation in which the science is changing and the politics are changing at the same time.
That's something Arlene Bloom is working on now. After her stint as a mountaineer, she did return to science. And one of her accomplishments has been going after the whole chemical regulation whack-a-mole game. Remember how they got brominated tris banned only to turn around and have to get chlorinated tris banned too?
So we've been promoting for about the last 10 years, thinking about chemicals in whole classes or families rather than as individual chemicals. So you don't first ban brominated tris and then chlorinated tris. You say, let's not use tris.
And it's working. People are changing their thinking from individual chemicals to whole classes. Arlene Bloom has worked with government other times, but funny enough, she's also started working with industry directly. She encourages them, sometimes successfully, to remove dangerous chemicals from the market willingly, which is what Bruce Ames did. So what are we left with? we kind of have this imperfect neoliberal system. Cancer prevention today is more focused on individual susceptibility and lifestyle at the expense of environmental exposure.
You also see the same thing with the FDA's move to label foods rather than ban certain things or regulate certain things. We're going to say that people should be able to make their own choices, and they can look at the nutrition label and figure out whether to eat this or not. I mean, there is a certain naive view of the amount of thoughtfulness that goes into consumption choices.
But the point is, we leave it up to people to make those decisions for themselves. And that focus on individual lifestyle management is actually where Bruce Ames ended up.
When I came back to science in 2006, I went to talk to Bruce first, and oh my gosh, he'd become so extreme.
Arlene says Bruce only wanted to talk about his latest obsession, diet and metabolism. He was convinced that what people eat or don't eat is the greatest danger to human health, not synthetic chemicals.
He had his business making, it was some food supplement that's going to prevent cancer. And so that's all he talked about.
Bruce and Arlene may have had their differences, but she still has immense respect for his work.
I think the test is extraordinary, powerful, important. I think Bruce should have gotten a Nobel Prize, but may not have because he became so outspokenly whatever. Yeah, and Bruce so generously sent it to everyone in the world for free. You know that. There were people in the lab that he paid who were full-time sending it all over the world so that people could do it, doing it for the greater good.
At the end of the day, cancer is a complex problem. And the idea that there's just one bad chemical or one bad company that you can get rid of and then everything will be fine, that's just a comforting but untrue story.
The knowledge itself is also highly uncertain. Our ability to predict things is really insecure. There's a lot we don't know, and the regulatory apparatus is complicated and has its own unintended consequences. There are also bad actors. There are interested parties, industry is acting in its own interests. So I'm not trying to deny that, but at the same time, scientific uncertainty plays its own complicated role. Even if there wasn't a distortion or concealment of information, it still might not be obvious how you improve the situation.
Distillations is produced by the Science History Institute. Our executive producer is Mariel Carr. Our producer is Rigoberto Hernandez, and our associate producer is Sarah Kaplan. This episode was reported by Rigoberto Hernandez and mixed by Jonathan Pfeffer, who also composed the theme music. You can find all our podcasts as well as videos and articles at sciencehistory.org/stories. And you can follow the Science History Institute on Facebook, Twitter, and Instagram for news about our podcast and everything else going on in our free museum and library. For Distillations, I'm Alexis Pedrick. Thanks for listening.